perhaps drifting into the philosophical, let me ask about the Big Bang as we kind of encroach onto it. So your work is kind of taking steps back through time in a weird way. Do you think we'll get to deeper and deeper understand the really, really early days of the Big Bang? And the philosophical question, do you think we'll be able to understand what was before the Big Bang or why the Big Bang happened? Do you think about that stuff?
Not with stars, for better or for worse, because, stars only probe the time when they were formed. Mm-hmm. And the Big Bang is surely before then. I mean, I often talk to my students about the difference between math and physics. Mm-hmm. Let me give you an example. Yes. We talked earlier about HE 1523, and I was happy to share with you that I measure thorium and uranium, but I actually didn't quite close that loop. So we did this to try to attempt to calculate an age for these stars, mm-hmm. right? But they rely on us knowing how the R process works, how these elements are created, where it happens, and then how those elements get dispersed into the gas and end up in the next generation star. So mm-hmm. quite a few question marks. So that's how we got to the age of 13.2 billion years. Mm-hmm. This is probably not accurate, but this is the best calculation we could do. And the reason why I'm bringing this up is that was actually the average of multiple elemental ratios that each gave a certain age, and then we averaged that because, for better or for worse, this is the best we can do. So some of these numbers said, oh, this star is 15 billion years old. Mm-hmm. And then others said, oh, this is 10 billion years old. And so I often use that in my class to say, like, what's the good news and what's the bad news here? Some ratios say 15, sometimes 10, right? Is 15 correct? And then I ask them, and some people will say something. And so the thing here is that it's an absolutely correct calculation given the mathematical and physical model that we constructed. Mm-hmm. But does it make sense? No, it doesn't. If we believe the universe is 13.8 billion years old, 15 is ridiculous, yet it is correct. Mm-hmm. Isn't that interesting?
Correct from a mathematics perspective.
It is not incorrect because this is what I calculated. Nobody made a mistake. Now, we can question whether that's a good model, but that's a separate issue.
So right? You're saying physicists are much closer to truth than mathematicians?
Well,
I'm just kidding.
It depends. It depends. Sometimes yes and sometimes no, right? So yeah. What our job as physicists is to take the mathematical model, calculate our numbers, and then ask the question, does this make sense, right? Now, in the case of 15, it doesn't, but we took the average anyway because that was the best we could do, right? So, all right, let's put that aside. Let's apply the same sort of thinking to the Big Bang, right? Math can tell us things that we as physicists cannot grasp because it doesn't make sense to us. Now, in the case of the Big Bang, that's a special case because we don't actually know what's supposed to make sense.
Yeah.
And this is where things get interesting. But this is where math will ultimately be the winner because we can no longer say this makes sense or this doesn't make sense because the physics is broken down.
But math breaks down too at the singularity of things.
Well,
or no,
depending on who you ask.
Okay. Sure.
This is the current question, right?
Yes.
How much further can we push math, let's say, to the front of the Big Bang, if there is such a thing?
What's the front and the back? What's the front?
Well,
the front is
before the Big Bang.
Oh, before
right?
the Big Bang.
Yeah.
The front. Okay. Yes. Just to clarify,
right?
all the doorways and the entrances.
So how far can we let the math go before that stops to make sense, right? And I don't know what the answer is to that, but it's really cool that because math is not limited by our physical nature, it can probably go a little bit further than the physics.
Yeah.
Right?
And math can go into more dimensions than 4 dimensions comfortably.
And it's judgment free because it just calculates things on its own. Whereas as physicists, we're so judgmental.
Yeah.
This makes sense. This doesn't make sense, right? It doesn't get any worse.
It's such a beautiful dance. And it's such it's so amazing that through this dance, you get to explore the origins of the universe. Like, doesn't the Big Bang just blow your mind? That this thing has just started from a point.
Yeah.
And now we're here.
Yeah.
Hydrogen and helium. And then all the stuff you're studying. I mean, this evolution of chemistry created humans. And we're here talking. And there's a lot more to the story. It's amazing.
Yeah.
And this kind of march that you're doing is observing data. And you're looking at old light and old data.
But only a few thousand years, right?
Just a few thousand years.
That's the difference between me and my JWST colleagues.
Yes.
Their objects, that light has traveled 13 billion years or whatever it was to us, and they're observing that now. My light has only traveled a few thousand years. Yeah. It's nothing.
So whatever you observe now is likely still going on.
Yes. These stars are alive and kicking and having a blast.
1,000 years. Just a few thousand years. It's all it takes. If we can travel close to the speed of light, maybe we can reach out there.
We wouldn't have any planets around those stars, though.
So is that a definitive intuition?
Well, what are planets made of? Elements, right? To take the Earth, it was all heavy elements, right? The universe needed to reach a certain stage first to have produced enough of all these elements to actually make a planet.
So on average, right.
So that took quite a few billion years.
So they're not going to have a mechanism for forming planets. You could have visitors probably, but the kinematics of that are weird, are unlikely.
Yeah, I would say so.
Okay. So they're interesting in that they reveal the early chemical evolution of the universe.
Yes.
Not that they could be good vacation spots, but not.
Well, if you like a warm. It's just no planet islands to go to chill.